In this video, we will discuss Geometry Congruent Standard number 5, and specifically Part 2 of Standard number 5. We have only one learning objective for this. Determine a sequence of transformations that will carry a pre-image onto its image. It's fairly straightforward. We are just looking at pieces that are saying we have the beginning, we have the end, how did you get there? For this particular problem, we can quickly identify that the bottom left is the image because they are the ones that are using the prime notation. Well, that's all that we're looking at doing then. How can we move this rectangle that's 5 wide and 3 tall over to another one that's 5 wide or 5 tall, 3 wide? That's all we're looking at doing. How do you move it? This is done pretty much with just mental manipulation. When you already have the images like shown, just look at it and think, how could you possibly get it there? For this one, I'm hoping that you guys can see that we have a rotation. If we were to rotate the image and spin it to the left, we'd be able to see that we could change the orientation so that A gets rotated down, B gets rotated over, C is rotated up, and D is rotated over. And then we can see how the coordinates are matching positions for what we have there for our image. The big question then is, if we're going to do this rotation, how far did we rotate it? Because it's great to simply say, well, we have to do a rotation. Anytime you talk about a rotation, you have to also talk about which direction did you rotate it. Did you go left or right? Did you go clockwise, counterclockwise? Besides talking direction, you also have to mention how far. Did you rotate it 90 degrees? Did you rotate it 120 degrees? Did you rotate it 3 corners? You have to have something that talks about how far you rotated. Now, maybe you won't be able to figure out the exact number of degrees, but you should still be able to have something that describes how far you're rotating it, because what if you mean rotate it all the way around? How far is part of it? And with any other rotation, we have to know the center. Which point are you spinning it around? If we rotate around point A, we know that will be different than rotating around point B, or rotating around the origin, or rotating anywhere else. We have to be able to describe all 3 of these things. What's pretty cool about this, though, is that we could do it in a bunch of different ways. There's not only one correct answer. So someone in the class, help me out. Which direction are we rotating this? Okay, Bobby gave it to me. We're rotating counterclockwise. How far? Okay, we can rotate it 90. Absolutely. We could also, instead of saying 90 degrees, we can say a quarter of a turn. That would be also correct. And then what point are we rotating around? This is one where it gets kind of fun, because we can rotate around a lot of different points. If we want, we can rotate it around point A and just turn it upward. We know if we're rotating on A, that means we're pinching it down on A so the whole piece spins around it. But we don't have to do that. We could rotate it around the origin and actually take advantage of our arrow notation that we discussed before. That works perfectly as well. I'll tell you what my preference is, though. I'm going to go right here. Now, why would I want to spin right there? It's the center of the shape. If you're spinning around the center of the shape, then when you're turning pieces, I know that I can start spinning it around, and that's great, but if I take it and spin it, come on, get me the right one. If I rotate it 90 degrees around, it's going to put it right there. And why that's very helpful for me is because now that we have the same orientation, I know that I'm going to have to do a translation over to the other one. But if we're talking about doing a translation, we still have to talk about how far and what direction. Where this gets to be, yes, I know. Where this gets to be particularly helpful, Braden was pointed out that when I rotated it, the A, B, C, D did not actually get rotated along with it, and so they don't match for the pre-image and the image. That's perfectly fine. I'm actually going to take this and rotate it back. I was just showing the shape to put it in the same orientation so that you could see I could rotate top left. I'm sorry. After doing the rotation around the center, it's pretty quick to say go top left to top left. That's a very quick translation to figure out because we can just count. More generally though, instead of saying top left to top left or bottom right to bottom right, it's very helpful simply to say let's go from center to center. How far up, how far over, or how far down and how far over. That's where we would be looking at our transformation. Now this piece I need to get rid of, and that piece I've got to rotate back the way it was, but we're still looking there. How far of a translation did we have? Well, let's just count. Starting off here, that's half. 1, 2, 3, 4, 5, 6, 7, plus the 2 halves. That tells me I'm going 8 to the left. Okay, so left 8. And then we're going down half, 1, 2, 3, plus another half. That's a total of 4. So we're saying down 4. All the pieces that I've been writing on this, actually writing down here, you don't need to have any of that written down. This is a piece that can be done completely and totally in your head. If you can mentally see a sequence that gets you there, that's all we need. Now that I have the idea where we were able to figure it out, we still need to write these out in complete sentences, which is why I asked you to say keep the right-hand side of the graphs open. That way you have space to write out complete sentences and not just be in a tiny little margin. So we could say, first, rotate the pre-image 90 degrees counterclockwise around its center. And you'll note that's a sentence that maps out the first transformation we said to do with this rotation. Second, translate that left 8 units and down 4 units. This falls on the final image. And so there we go. In this particular example, we were able to just walk through it in only 2 steps. We were able to get our answer. We were able to write up a couple sentences that describe it. We have everything that we would need. Continuing the problem. And by the way, if you need to pause the video to get some more time, or if you need to backtrack through the video, by all means, go ahead and do it. It's not like you have to sit and watch this in one straight sitting. Okay, let's consider this one. How are we going to get them moved over? At first glance, yeah, it looks like we could just take the left-hand side, the pre-image, and flip it over. But when we flip it over, what's going to happen, when I say flip it over, I mean a y-axis reflection left and right. Will we have the points matching up? No, they're not. The shape will. You're absolutely correct. Students in the class, Bobby was noting that this gap of 1 to the left will match up to the gap of 1 to the right, and so it will put this perfectly on top of each other. But the points don't match, and that's still a problem. And so there are ways that we could fix that, but sometimes they're going to be a little bit tougher to see. Remember, there is more than one correct answer. For this particular one, we talked about in a previous class, if we had this, because this is an isosceles right triangle, we would actually be able to reflect across this line, and that would refold it over. What I mean is, if we did the y-axis reflection, we would have C prime and A prime. But if we then reflected across this red line, that would that would get them to match up. So we can still do it that way. That is one correct answer. But that's a little bit tougher one to see, and it's not part of our standard reflection, rotation, translation of the normal lines. So, can we identify something else? Okay, we could do a reflection and then a rotation. A couple other people are motioning with their hands, so please tell me, what are you seeing? Okay, so if we rotated 90 degrees counterclockwise, that would be noting taking the shape counterclockwise. That would also rotate them over so that we'd have B. C gets rotated up. A gets rotated down. And then we'd be able to do just a quick translation over. So we actually had two different correct answers. We had one correct answer of a rotation, 90 degrees counterclockwise around the center. And I used around the center simply because that's what the smartboard always does when I use the green dot for spinning. Then we were able to do a translation, which would have been right 7. That was one correct answer, absolutely valid. But people also, just before that, pointed out that, I gotta spin this back, we had another correct answer where we did a reflection across the y-axis, and then we did this reflection across that line. And that's a badly drawn version of that line. If you choose to do this particular route, you will need to figure out the equation of the line. So you'll have to take advantage of some of your previous knowledge from Algebra 1, where you could set up slope-intercept form, get the equation. We have two different correct answers. Which one would you rather write out? And that would be +7. Two different correct answers, but we have them. We could do either one. Do you have a preference on which one you want to write up? Okay, people are motioning to up. Of course, you can't see them motioning on the video, so we'll do the one in the red. First, rotate the pre-image 90 degrees counterclockwise around its center. Then slide it right 7 units. 7 units to the right. And we have our answer. I remember I had a student last year actually struggled with seeing the sequence. So they kind of did some guess and check and started moving pieces around, and they had one problem where they did 7 motions to get there. But it was correct. Obviously, doing 7 movements is not the most efficient way of doing it, but they were right, and so they got complete full credit. The standard that we're looking at, our learning objective that we have, is determine a sequence. The standard is not do it in 1 step or 2 steps or 50 steps. They just say get the job done. So as long as you can identify any correct sequence, you are meeting what the standard says. Obviously, you don't want to do 10 steps. You don't want to do 5 if you can get it done in 2. 2 steps is less work. 3 steps is less the work than 7. But at the same time, you also have to admit it is a little bit impressive that they could follow 7 steps correctly without moving anything or without making a mistake on anything. So there's still, good parts to have from there. Here is our third and final example. Specify a sequence of transformations that will take this pre-image onto the image. And I promise you this time, it's not a 90-degree counterclockwise rotation. So what do you think? How could we move it? Okay, we have several different ways of doing this one. A big part, or a common answer that students will give is they'll say, well, I can still do a rotation around the center because that is such a nice technique to be able to rotate around the center. But what they wind up saying is this point of A needs to match up to A prime for the image, so they'll say, I'm going to rotate this to the left, and I'm not asking you to specify the number of degrees, but rotate it to the left 3 corners, or 3 vertices. But what happens with point B when you do that? If you rotate this 3 to the left, so A would go 1, 2, 3, and it does get the correct location matching what we had for A prime. But when you take B, 3 rotated to the left, 1, 2, wait a minute, 1, 2, 3. I skipped A. I was like, wait a minute, I'm doing something wrong. I skipped A. 1, 2, 3. We wind up putting B prime here, but that B prime does not match H prime. We've got a problem with that rotation then. That's not to say that we can't have this be correct. That's not to say that we can't start with that. It's just, it does not get us the instant matchup that we were hoping to see. Specifically, one of the pieces that we'll note and be a big clue as to whether or not you have a rotation is the direction of the numbering, or the direction of the vertices. You'll note on the last ones we were doing, when we go A, B, C, D, the order was spinning around or tracing around going to the right. And when we go A prime, B prime, C prime, D prime, it's still being traced and labeled in a clockwise fashion. Same thing happened with our second problem. A went to B, went to C, it was labeled in a counterclockwise fashion. Same thing with A prime, B prime, C prime was labeled counterclockwise, but the directions of the labeling were the same. Because the directions of the labels were the same, that's a good indicator that we had a rotation. But that does not follow through here. In the pre-image, A, B, C, D is being rotated or labeled clockwise, but in the image, A, B, C, D is being labeled counterclockwise. That's where we need to get reflections. Think of the mirror. You raise your right hand in front of a mirror. Does the mirror have its right hand label raised? No, your mirror reflection would look like it's raising its left hand. That's what's going on here. When those directions of the labels change, it's because they got reflected. And you just need to figure out one type of reflection that will work. There are a lot of them, but that's an important clue for you to notice. A change in direction will cause the change in the labels. Now, what could we do to actually get them there? Braden is pointing out we could reflect it down. And he didn't say reflect it across this one. Braden was actually saying reflect it across the x-axis. And let's actually do that. We'll back up, we'll take Braden's strategy and reflect this down across the x-axis. When we do that, this gap of 2 with a gap of 2, we'd have it here, then here, and over, and 2, and over, and 2, over, 2, and we'd wind up with this piece, understanding that my sketch is probably not perfect, of course. So when we reflect it, that gives us A prime, B prime, C prime, D prime, E prime, and you'll note the order of the points matches. So this is one correct start. We could do a reflection across the x-axis. Then what? Okay, we'll do a slide or a translation. To the left, how far? Well, basically we just have to make sure we have some set of matching points. If it were me, I think I would take A matching A. You can actually draw the right triangle. If you had a right triangle, or simply note it goes straight over, which would give us 8 to the left, and we don't have to worry about up or down. That's one correct answer written in red. Absolutely valid, completely, totally correct. I admit it's not the one that I saw. The one that I saw, because I really like working with the center as a strategy, I saw reflected across this line. Given that it's a horizontal line, we know it's of the form y equals a constant number. And since it's crossing through this height of 4, that's reflected across y equals 4. And then I would have a different translation. I'd still have to go to the left 8, but matching up center to center, 1, 2, I should do this in another color so we can see. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8 down. And there we go. We have a different correct answer. They were both valid methods of moving it from the pre-image onto the image. And these are not the only ones. We could have done a reflection followed by a rotation followed by a translation. Because another correct one that we could have done, people are looking at me like they don't see which one I'm talking about. We could have reflected it vertically, which would have given us A prime, B prime. And if we then rotated that all the way around upside down, 180 degrees, we get that pair. A reflection followed by a rotation followed by a translation. We could do it in 3 steps. There are many, many, many correct answers. You just have to have one set that's correct. Doesn't matter if it's 1 step, doesn't matter if it's 2 step, because our learning objective for congruence standard number 5, our second part, is very straightforward. Determine a sequence. Not the most efficient sequence, not the best one, not the prettiest one, not the one that your teacher sees, but see one correct sequence that's going to get the job done. If you can map that transformation, that sequence of transformations, write them up using complete sentences, then you are able to fulfill this part of the standard, and you'll have the appropriate understanding for it.